So you've got this massive orders table, we're talking millions of rows, and you need to partition it by date. Problem is, you can't afford any downtime. And you definitely can't lock the table for long periods while you're shuffling data around.
Right? So how do you even start? Can you just turn a regular table into a partitioned one?
There are ways to convert in place, but they have limitations and can be complex. The safest pattern is to create a new partition table, then backfill data from the existing table in batches. We're going to walk through the whole thing, the setup, the migration, and the validation, step by step. All right, let's start with the core approach that makes this whole migration possible. While Postgres does allow converting an existing table to a partition table, it requires specific steps and conditions that can be tricky. The safest approach is to create a brand new partitioned parent table and then move your data into it.
And copying millions of rows in one go would take a long time, right?
Exactly. If you tried something like insert into new table, select asterisk from old table, you'd be running one massive transaction. That's where the batch migration pattern comes in. It's a way to move data incrementally without tying up resources for extended periods. Here's the 5-step plan. First, you create a new partition parent table. It's just an empty shell with the same columns and the partition key defined. Second, you create the actual date range partitions you want. They start empty.
So at this point, everything is ready but empty?
Exactly. Third, you backfill data from the old table into the new partitions in small batches, so each transaction completes quickly. Fourth, once all data is migrated, you switch your application to use the new table. Finally, you drop the old table and you're done.
That makes sense. You're doing the data migration in the background while the app keeps running normally.
Right. The key is keeping each batch small so transactions complete quickly. All right, let's look at the actual SQL to set this up. You create the new parent table with the exact same columns as your existing orders table, but you add partition by range on created at. This table is just a shell. It doesn't hold any data itself, only the partition definitions.
And at this point, I can't insert into it yet, right?
Correct. If you tried, Postgres would complain there's no partition to route the row to unless you define specific partitions or a default partition. That's why the next step is to create the actual partitions. Now you create the actual partitions you want, typically one per month or week, depending on your data volume. Each partition is a real table with explicit bounds. You also create indexes on each partition as you go, because Postgres doesn't inherit indexes from the parent.
So if I had a B-tree index on customer ID, I need to recreate it on every partition?
Exactly. You can script this, loop through your partition list, and create indexes on each one. The partitions start empty, so the index builds are fast. Once they're ready, you can start backfilling data into them. Now for the heart of the migration, moving data from the old table into the new partitions with minimal impact on your app. If you tried to move all the data in one go, you'd have a very long-running transaction that could impact performance. Instead, you move data in small batches, say 10,000 rows at a time. Each batch is a separate transaction that completes in a few hundred milliseconds.
And I can control the pace so I don't spike the load on the database?
Right. You can add a sleep between batches or run the backfill only during low traffic hours. The key is that each batch is an insert into the new partition table, selecting from the old table based on created at. Here's the backfill pattern. You select a batch of rows from the old table, filtered by the date range you're backfilling, and insert those rows into orders new. Postgres automatically puts them in the right partition based on created at.
So I'm just copying data from the old table to the new partition table in chunks?
Exactly. You loop this in a script. Each iteration moves another batch. You can track progress by checking how many rows you've migrated for each date range. When a range is fully backfilled, you move on to the next month or week. A few things to watch. First, make sure your where clause uses an index column, typically created at, so Postgres can find the batch quickly. Second, commit each batch in its own transaction so it completes fast. Third, keep an eye on replication lag if you have replicas, because each batch generates well.
What if the script crashes halfway through?
Good question. You should log your progress, write the date range and row count of each completed batch to a tracking table. That way, if the script dies, you can pick up where you left off. And always use a limit so each transaction touches a predictable number of rows. By the way, once you've created all these new partitions, you need indexes on each one. My DBA's free health check analyzes your schema and query patterns, flags missing indexes across all your partitions, and suggests create index statements to run. It's automatic, and it catches the indexes you'd otherwise forget. Here's an important step to understand: adding constraints efficiently. When you add a check constraint to a table, Postgres by default does a full table scan to check all existing rows satisfy the check constraint, which can take minutes on a huge table.
Wait, so even though I've already backfilled the data correctly, Postgres still scans it all?
Yes, because Postgres needs proof, but there's a trick. You can add a check constraint marked not valid, then validate it separately later. The not valid flag tells Postgres to skip the scan initially, so adding the constraint is much faster. Here's the pattern. You add a check constraint on created@ with the exact bounds, and you mark it not valid. This tells Postgres the constraint exists, but hasn't been verified yet. The constraint is added quickly because Postgres skips the scan.
So when do I actually validate the constraint?
After adding it, you run alter table validate constraint in a separate transaction. That does the scan, but it's less disruptive when done separately. This validate constraint command scans the table to prove every row satisfies the constraint. It takes time, proportional to the table size, but it allows reads and writes to continue while the validation runs.
And if the validation fails, what happens?
If there's a row that violates the constraint, the validation fails and you get an error. That means you backfilled data into the wrong partition, so you need to find and move those rows. But if your backfill logic was correct, the validation will pass and you're done. Once all the data is backfilled and validated, you're in the home stretch. First, you verify all data has been migrated. Compare row counts between the old and new tables. If they match, you're ready. Then you switch your application to query orders new instead of orders. Monitor closely for any issues.
How long should I wait before dropping the old table?
Give it at least a few days of production traffic to make sure everything works correctly. Once you're confident, you can drop the old orders table. You might also rename orders new to orders so the app code doesn't need to change permanently.
And at that point, new inserts automatically go to the right partition?
Exactly. Because you defined the partitioning strategy with partition by range on created@, Postgres routes every insert to the correct partition based on that column. Just make sure your partitioning setup is maintained correctly after any table operations. Once you're partitioned, you need a plan for creating new partitions before they're needed. The PG-partment extension is great for this. It can automatically create the next month's partition a week in advance, so you never have a gap. It can also drop or archive old partitions on a schedule.
What happens if I forget to create a partition and an insert tries to go there?
If there's no matching partition and no default partition, the insert fails with an error. That's why you either keep a default partition as a safety net or you automate partition creation. Most people use PG-partment or a simple cron job that runs create table if not exists for the next few months. Here's the payoff. Before partitioning, you had one giant table, slow scans, bloated indexes, vacuum taking forever. After partitioning, queries that filter on created only touch the relevant partitions. Indexes are smaller and faster. Vacuum and maintenance are scoped to one partition at a time.
And I can drop old partitions quickly instead of deleting millions of rows?
Exactly. Drop table on a partition is generally faster and generates less wow compared to deleting rows. Partitioning gives you much better control over data lifecycle and performance. If you're planning a partition migration, or you've already done one, My DBA's free health check will analyze your schema and flag missing indexes, bloated tables, and constraint issues across all your partitions. You connect your own database, and within minutes, you'll get a comprehensive health report graded across 16 domains with the exact SQL fixes you need. It keeps running every week, so you catch problems before they become outages. Head to mydba.dev and try it free.